Okay, we are recording now. Let me just do that one. And then I'll that one. All right, so you can see the screen with the slides and all that jazz.
Yes.
Okay, so let's talk about the breakdown for grades in the class, first of all. And then we'll just jump in and start going, and we'll go until about a 9:20 or 9:22 or so today. Um, I think what we'll do for class meetings is, I mean, I think the class is scheduled to go at 7:40, which is pretty early. Um, so I'm thinking what we'll do is we'll go class meetings will be online and in person. 8 a.m. Mondays and Wednesdays. You should attend in person if at all possible. May attend online if that is necessary. So, having said that, I know some of you live significantly off campus. And if you rely on the bus and the bus doesn't come at the right time or something like that, I'm relatively okay with you attending online. But officially, I'm telling you that you have to or should make every effort to come to class in person. So use your best judgment for what's best for you. I will attempt to have every class meet in person. Um, so if you would like to come in person, which I encourage you to do, we will. I didn't actually scope out the classroom, but my plan is meet in um, S. Let's try 109, the old fishbowl, um, starting this Wednesday. But we will see if another classroom is better, because this early, all the CS classrooms should be open so we can browse and decide which which we like the best. But I'll always be online with Zoom as well. So if for whatever reason you aren't able to get to campus on a certain day or that early, um, you have my permission to attend via Zoom as an alternative to missing class. But I do encourage you to show up in person. Questions about that?
Oh, was there any reason to choose this time?
Well, you mean early or um, for when it ends?
I mean, like 8 o'clock. Is there any reason to choose that time?
Well, I don't know. I like early classes.
Okay.
Gets us up, gets us moving, gets the coffee flowing. Um, like I said in the email, right after class, um, I go down to chapel here on campus. So all of you are invited to come. I know not all of you are Christian, but you know, coming down, they sing some songs. There's a little sermon. It's like 25 minutes long or so. But I mean, it from an education perspective, it will educate you on some of the things that your classmates and uh, faculty at Concordia believe. So um, I invite all of you and encourage all of you to come to that. We sit in the front row. We have a club, the computer science club in the first row. So nobody's going to be giving you Kool-Aid to drink or anything like that, trying to convert you from whatever your religion may be. But I do encourage you to take part in that activity. That's why we'll be stopping at like 9:20 a.m. Each day to give enough time to walk down to chapel. This is not required. it's strongly encouraged that you spend 20 minutes of your day going down and um, participating in that thing on campus. All right, so that kind of answers that question. I mean, the rationale. So there's two rationales. First of all, for early class meeting, one is I just like early classes. I like getting up. I like to have an excuse to get out of bed. And frankly, and most of you probably noticed, I was in a funk last semester, and we're not going to do that again this semester. So I'm getting up, getting going, getting over to the office, and we're going to have early classes. On top of that, there actually is a legitimate rationale. The university is running out of classrooms. So it's very, if you remember last semester, I mean, part of the reason we met online, other than me being in a funk, was, we were kind of at the, we had to kind of bounce around classrooms to find a place where we could go. So because of that, early morning classes typically don't have that same problem with classroom availability. Let's call that a secondary thing. I'm sure we can find a classroom at other points of time in the day, but we're going to call this, the other rationale. But bottom line is, let's just get our butts out of bed and start and start our day. Feel free to bring coffee. Or whatever. If I get into the habit of it, I don't want to promise it, but I might bring donuts to class. Um, uh, just swing by Meyer on my way to school if I can get my butt out of the door early enough. But so I will try to do that at least once or twice. But if I can somehow make it a tradition, I'll provide breakfast with donuts. Uh, no promises, but it's the intention. All right. Other questions about class meetings? And this class meets for the first 8 weeks of the semester, whatever the end date is. We'll get the dates figured out once we kind of get rolling. But and then the next 8 weeks, you'll have another class with me, which will be the RESTful API class. I think it's same time, same station. So bright and early, whole semester. But we will switch topics halfway through. I know some of you were concerned about the amount of programming in the 560 class. We ran it last semester online, and it was a lot of programming. So I'm going to try to change it a little bit. I know some of you don't have a lot of programming experience. I'm not going to let you use that as an excuse, but at the same time, I want the class to be kind of a reasonable workload. So we'll tweak it a little bit. We'll use a lot of in-class examples and things like that. But let me go this route. Programming practice. So this goes for all of you across the master's degree. It's a little bit of a slippery slope, let's say. It's, on one hand, we want to, well, let's go this route. On historically, people who go on and get a master's degree are maybe 30% of the time kind of switching careers, switching academic paths, something like that. Or I mean, it could be a drastic change, or it could be, just a little bit of a pivot based on what your undergrad is in. But this isn't just a Concordia thing. When I was in grad school, it was common for some of my classmates not to have a computer science background. Now, with that in mind, what does it mean to have a computer science background? Well, I'm going to make the assumption that you have the competencies from, what we would have in our undergraduate computer science program. Now, here's the rub with that. Many topics, like, let's say, database or operating systems, or even software engineering. Not that these are not important topics. In fact, I'd say in many cases, those topics are real computer science. Okay, that's the core components of computer science. But because there's a lot of theory in those classes, it might be easier to catch up with any deficiencies you have in those classes by going and reading a book, doing some online research and stuff like that. Now, programming, on the other hand, and this is where it gets a little flip-floppy. A lot of students have this perception that computer programming is computer science. Not the case. Okay. In fact, I would say that the way I like to put it is computer programming is the tool that a computer scientist often uses to solve problems. With that in mind, um, the you do need to get some competency in computer programming. The problem is that to get that competency in computer programming, you have to put in some reps. You have to put in some practice. You can't just go and study a book and be good at it the next day. The example I used with our couple of newer students, and I'm assuming that a lot of you, the sport of choice in your at home, or at least a popular sport, would be cricket, right? So, as opposed to basketball, I guess I would say, or American football, for example. By the way, today's going to be a good people watching day. So if you just want to go sit at a coffee shop or something like that and just watch the people mope in and out because the Packers lost, I would encourage you to do that if you haven't. It's really a phenomenon in Wisconsin. I came to Wisconsin in 2006. They wouldn't give me a driver's license until I pledged my allegiance to the Packers. But yesterday was a big game to try to get to the Super Bowl, and we lost, which I kind of predicted. The Packers typically, I have found, do well when they're underdogs. When they're supposed to win, the pressure gets too much or something, but whatever. But in any case, Wisconsin almost views the Packers as somewhat of a religion. So the fact that they lost yesterday would means there's going to be a lot of depressed people today, and I find that fun to watch. So do your grocery shopping or something like that today, and you can just kind of watch the misery. But in any case, and let me switch things here real quick. I want to, well, actually, I'll do this. This will be better. I'm lost. There we go. And we're back. But I do want to do, what do I want to do? Whatever. Let's say that's good. But in any case, I do want to provide you with the tools that you need to catch up on any computer programming deficiencies you might have. Now, at the end of the day, you're all adults. You can decide if you want to take advantage of these tools or not. But I'm going to make the assumption that you have the reasonable programming background to be able to complete your assignments. So it's going to be on you to pick up the slack for any of those things. But if you feel like you need some programming practice or would like, to brush up on programming practice, send me an email. So ask for programming classes, and I will reply with links to all three of our undergrad programming classes, along with slides for each of them. So maybe instead of binge watching Netflix or something, you can go through the programming classes. I would say for most of you, the most important class that you get a strong foundation in is the first class, CSC548. That's the class where we kind of introduce computer programming concepts, assuming you've never seen programming before. The language we use is Python, which we'll talk about kind of the programming language we'll use in here in a little bit. But bottom line is this introduces you to the concepts of computer programming. I teach programming from the perspective that the language does not matter. You learn programming as a skill set, and if you're learning that in Python or Java or C#, it doesn't matter, because under the hood, what you're doing is you're learning about computer programming. And just to give you the quick, one slide version of that, you know, humans solve problems using three things. We use our memory, we ask questions, and repetition. All right, that's how we solve problems. 100 so now we say the job of programming languages is to allow a human to tell a computer what to do in such a way that they can solve problems similarly to how they solve them in real life. So a programming language is a power tool that converts human problem solving into something the computer understands. And that's what this course is going to be about, abstractly early on, and then we'll specifically get into the idea of mobile and some programming for it. With that in mind, I'll steal this slide. "100% of programming languages have facilities for the following: memory, this is usually done through variables; asking questions, this is conditionals, if statements, etc. And repetition, this is loops, functions, subroutines, procedures, whatever your particular methods, whatever your particular language supports. Functions, let's say, is the generic term across the board. Some older languages have the idea of a function as something that returns a value. Procedures are something that don't return values. Object-oriented languages puts everything under the guise of something called a method, but these are effectively reusable chunks of code. But then on top of that, we have loops. But punchline is that 100% of programming languages have tools built into them that allows us to mimic human beings' memory, ability to ask some questions, and the ability to repeat stuff over and over and over again. So whenever you learn a new language, if you can figure out how to accomplish each of the above in that new language, you can immediately solve a large collection of problems in that language. All right, make some sense? All right, so that's kind of the idea. So from an academic perspective, what I want each of you to do is I want you to have a competency in computer programming. I don't care what language you've done it with, but some tool where you've had to mimic memory, where you've had to ask questions, and when you've had to do some repetition, and then have had the reps, put in the practice, like it's a sport, to practice solving problems where you are telling the computer what to do. Sometimes those might be interesting, solving real life problems. Other times it might be you're solving some little stupid puzzle for a homework assignment. But whatever it is, I want you to have the practice for that. So with that in mind, if you email me here, I will send you the full courses with YouTube videos for all the lectures, and I assign the homework assignments at the end of each class. So you can go through the assignments if you want. I usually solve them at the beginning of the next class. So if you wanted to try the assignment on your own and then see the solution the next class, you could do that. If you want to expedite your journey, I would still encourage you to practice, but you could kind of maybe spend 5 minutes thinking about how you would go about it, then watch the solution and maybe follow along with that solution and type it in. And then eventually you'll start being able to do it on your own. I'm just kind of operating from the idea that, you know, all of you should be more mature students, know how to learn relatively quickly, things like that. So if you're looking for a way to get through that first course quickly, you might binge watch it with that in mind, and then maybe do a couple of the assignments or come up with your own little practice things or something like that, just to kind of drill yourself. All right, questions about the programming practice stuff? Okie dokie. Grade breakdown. So there will be Bible homework in the class. I'm looking, historically what I've done in my classes is each week there's something you read from the Bible, and then you write like a little, like a paragraph or something like that, kind of response to it. Because these classes are only 8-week classes, I may deviate from that a little bit this semester and instead have like 1 or 2 Bible homework where you maybe read a little bit more and write like a 1 or 2 page response or something like that. But those will count as a different than normal homework. That's your Bible homework. So bottom line is, I'm forcing you to read the Bible. You can love me or hate me for that. But I'm forcing you to read it, and it's worth 10% of your grade. So if you don't do it, you can't get an A in the class, is what it comes down to. So again, I know that some of you have different religions than Christianity, but Concordia is a Christian school. You know, I don't want to attack any of your religions, but at the very least, I want you to learn about mine and learn about the religion that the university follows and your other teachers are going to have, and things like that. And, you know, then if you have questions and you want to go to chapel, and I invite you to come to my church and all this stuff, you know, feel free to talk to me about that. But I'm a computer science professor, not a pastor, so I'm not going to sit here and berate you, but I'm going to give you lots of opportunities to explore the material. Sound good? Regular homework will be 60% of your grade, and then we'll have 1 exam. I usually like to give 2 exams in my classes, but since it's only an 8-week class, I'll only have 1 exam. We may have some in-class quiz type situations where I have you solve something as like a quiz in class that would count as a regular homework assignment to give you some, you know, encouragement to keep up with the class material and make sure that you're learning and stuff like that on your own. All right, make some sense? All right, next.
Question.
Yep.
If we do online, how are we gonna take the in-class quiz?
I'll put it on Blackboard.
Okay.
All right, so academic dishonesty. This is something that all of you should have a background in. I know a lot of different cultures have different approaches to collaboration and things like that. So one thing I ask you all to do is make sure you understand each of your professors' policies related to collaborating on homework and stuff like that. In my classes, I encourage you to collaborate on homework to maximize your learning. All right, so when I give a homework assignment, I'm not going to sit there and look to see if so-and-so copied off of somebody else. Okay, I'm going to find out on the exam whether or not you are you've learned the material. So however you want to accomplish completing the homework assignments is fine with me, as long as ultimately you feel you're learning the material, because 30% of your grade is that exam. And if you bomb that exam, well, now you can you know, earn a C- in the class with a 0 in the exam, right? Even if you ace everything else, and you need to maintain a B GPA to graduate from the program. So it would not be in your best interest to not get out of the homework what you know, not to learn from the homework. All right, I view computer science, I view education as kind of like a sport where, you know, homework is there for you to practice, like you go to this, your practice for your sporting team. And then the big game is the exam. That's when you, all that practice should come to fruition and you actually perform well. Okay. So I encourage you to collaborate on homework assignments. I'm not going to look for people who, you know, cheated and stuff. I really encourage you on the Bible homework assignments to do that on your own. But again, I'm not going to sit there and, I mean, if 5 of you turn in the identical paper, I think you're only hurting yourself, but I'm not going to sit there and try to police that. I'm not going to ask questions on the final exam related to the Bible readings. That's something that I want you to participate with in the class as part of education from Concordia, but not something that's part of the topic of mobile computer architecture. But again, I want to emphasize that all of you should make every effort to understand what your teacher's policies are related to academic dishonesty in each of your classes, even if you've had the teacher before, in case they have a different approach in one of their classes, so that you don't get caught up in a problem where, you know, you work on homework together or something like that, then get caught cheating and get turned in, because just because Dr. Littman allows you to do it doesn't mean your other teachers will. Okay, everybody get that point? All right, so let's jump into some topics for computer architecture in general. So when we compare computers to each other, and I almost want you to put yourself into the shoes of somebody who's shopping for a new laptop. We'll get a little bit more specific to mobile here before too long, maybe next class or something like that, but we'll bump into something here in a minute. But let's say you're shopping for a new laptop. What are some things you look for? So if you're buying a laptop, you know, let's say I give you $1,500. You have $1,500 to spend on a laptop, and you're going to try to get the best laptop that you possibly can for you. What are things you look for? What's important to you as a student, as a IT professional, whatever? What's important to you from a computer perspective?
Processing speed and number of cores.
Okay, so processing speed, number of cores. Why is that important to you? Do you want the fastest processing speed? Do you want the maximum number of cores? We'll talk about what that means in a second, but do you want the absolute fastest?
No, number of cores is important for me rather than the.
Okay. How many cores is enough cores?
Come again? I didn't get that voice clear.
How many cores in the processor is enough cores? I mean, if you were debating between a quad core processor and a 200 core processor, I'm just making up something. Is a 200 core processor necessarily better than a quad core processor?
I mean, depends on the application we use.
Okay.
And more of course doesn't mean it's a better processor.
Okay, so what are some applications that would benefit from multiple cores? And we'll talk about cores here in a minute.
I generally work on multimedia stuff like After Effects, and also number of cores is necessarily important for me to do multitasking and all.
Okay, so basically when you're dealing with a computer processor, and when he says multiple cores, we can kind of use that word core and think of it as a single processor, or the ability to do one thing at a time. Okay, one core on a processor allows you to accomplish one task, whatever that is, at a time. And we'll talk about that here soon. All right, what those tasks might look like. So having a processor that's like a quad core processor allows you to technically do 4 tasks at the same time. Now, just like in real life, some things can be accomplished simultaneously. You know, some of us are good at multitasking in real life, but other things have to happen in a certain order. The example I use is a lot of times with cooking, right? You can't bake the lasagna until you've already put all the ingredients together. Okay, so some things have to happen in a sequential order. So having more cores, having the processor having the more of an ability to do more things at the same time only benefits you if you are in fact doing things that can be done in parallel. So multiple cores, a dual core or a quad core, probably is almost always beneficial. A quad core is probably almost always better than a dual core, just because doing four things at once is something that's going to be pretty common on your computers, even if it just means you have four simultaneously running applications and you want them all to be getting CPU time most of the time, something like that. All right, so quad core probably makes some sense. But 200 cores, if you're spending a lot of money on 200 cores, not that you necessarily can buy that, but let's just play. All right, if you're spending a lot of money on that, you're getting something that you're likely never going to use. Kind of like buying a car that can, tow 4 million tons, and you only drive on the interstate. You don't actually tow things, and you got a lot of power you're never going to use. Okay, so one thing you look at is processors and number of cores, things like that. Okay, what else do we look at when we're buying our laptop? So, when we think about starting with our $1,500, where we want to spend enough money on the processor such that it allows us, it's compatible with the way we intend to use the computer, but we want to balance that against some of the other features we need for the computer. So what are some of those other features that would be important to you and why?
Memory.
Okay. What's memory in a computer used for? And why do you want memory? And how much memory? Let's start with that. How much memory is enough memory in your computer?
I mean, to in present generation, its minimum requirement is 8 GB.
Okay. So 8 GB you would say is the minimum you should get. But if you're buying a computer and I've given you $1,500 in a budget, would you get more than 8 GB, or would you stick with 8 GB?
For $1,500, I might get 16 GB if I get compromised a little bit between processor and the graphic card.
Okay. So maybe 16 gigabytes for a person who's um, commonly using a computer for kind of professional purposes. You could even maybe start making an argument these days for 32 gigabytes. Mostly overkill probably for most people's applications, but um, the reason I mentioned that, and using let's use Apple as an example. So we think of Apple computers as kind of like our premium product, right? They're like our Cadillac. It's still a computer, still has the same parts on the inside. It'll, just like a car. You can go and buy a Cadillac, or you could buy a Mercedes, but that's going to get you to work. But so will a cheap $500 used car. That'll get you to work too, most of the time. And Mercedes and Cadillacs can break down as well. Okay, but the punchline is it's more about traveling in style as opposed to it being practical, right? So if we think of a Mac as being our premium product, one issue you run into with Apple computers is because since their focus tends to be on design, and I don't think anybody would really have a strong argument to say that Apple laptops are probably better built in terms of structural design than Hewlett Packard laptops or something like that, but it also comes with a price tag, right? So that's not necessarily, I mean, just be careful with it. Something like that. But if we look at Mac laptops, almost the entirety of what's inside the thing is battery. The entire computer system lives kind of on a chip. So when you buy your memory, when you buy that laptop initially, and you spend your $3,000 on it or whatever it is, you have to put as much memory as you think you're ever going to need in there because it's not upgradable. I'm on a MacBook Pro right now, and I use a MacBook Pro because I virtualize other operating systems. We'll probably spend some time. So let's see. Didn't I have one of my other virtual machines running here? Yeah. So this is Ubuntu Linux running on here. So I run multiple operating systems at the same time on my laptop. And that's kind of the rationale for why I want to have these extra resources. So if I show you on my laptop, so I have an 8-core i9 processor and I have 64 gigs of RAM. So that's a lot of RAM, but this laptop I'm on here can't be upgraded. I can't put more memory into this laptop. So when I originally bought it, I just maxed it out. How much RAM can I get in this machine? And that's the amount of RAM I will have in that machine forever is the idea. And I do run multiple virtual machines at once, so those resources are beneficial. So having said that, when we talk about system memory, so 16 gigabytes, 32 gigabytes, 64 gigabytes, what does that kind of stuff allow us to do? What does having more gigabytes allow us to solve? So a couple of minutes ago, you said, the current trend is, you need a minimum of 8 gigabytes. What happens if you only had 4 gigabytes? What would happen today if you had a computer that had 4 gigabytes in it?
I mean, the system kind of works like it's between lag.
Okay. So you said lag, like how would you experience that lag? You're using the computer and you're working on Microsoft Word, and then you switch over to something else, and there's almost like a delay. You start typing or something like that, and the machine is doing something in the background.
Yeah, if you open Google Chrome and if you click on 3 tabs, and if you want to switch between the tabs, it might probably give some delay in switching the tabs.
Okay. Do you know why that is?
I don't know.
Okay. So your computer, and we're talking about this stuff at a high level, and as we get into this course, we'll talk about some of these things at a much lower level, because this course is all about talking about how the inside of the computer actually works. But we want to think about what the outside of what the reality of our computing journey is all about, right? Before we can really gain an understanding of how these different things actually work on the inside. So every single time you open up an application on your computer, it's going to take up some memory, because what happens is when you open up an application, that application is going to live on your hard drive, and we'll talk about that in a few minutes. It's going to live on your hard drive, and when you double click on the icon, it has to load parts of that application into memory. Okay. When we think about a computer, and we're going to talk, that's kind of what the slide's all about, is comparing computers. We have this concept of memory, and memory, like we talked about a few minutes ago with programming, is the idea of remembering things, right? Now, we have different technologies in our computer that allows us to remember things faster. Well, really, it's not remembering them faster, it's recovering that information more quickly, accessing something that's in our head more quickly. All right, so if somebody asks you what your name is, you hit your brain, your memory location, your memory storage, and you look up that information, you spit it out. All right. You know that's going to be faster than having to go and look something up in maybe you have a note somewhere, like what's your bank account number. Okay, most of you probably know your name. That's something you remembered. Probably know your social security number. Some of you might not, and this is maybe that unique group, because when you work in the United States, you get a social security number, and perhaps you haven't memorized that yet. You have it written down somewhere. But or even your phone number here at Concordia, the first several times you've needed it, you probably got to go look it up. Like, oh, what's my number? Right? You look at your student ID, whatever. That takes longer than when you just recover it from inside your head. So we can recognize that in real life, we have some different performance ways of storing information, right? And the information that we need readily available, like what's my name, is something we're going to keep pretty close to the actual engine of going through life, because that's something we want to be able to, you know, grab whenever we need it. Where if every now and then you need your social security number or your food number, or, you know, a bank account routing number, whatever it is, it's more okay for us to have those stored someplace else that we have to spend a little bit to go look it up when we need it, right? Okay, so in real life, we do have different speeds of memory stuff. Now, our system memory, the thing we're talking about here, where you might have 8 gigabytes, 16 gigabytes, 32 gigabytes, whatever, this memory is considered to be pretty fast. Almost think of it like our, you know, maybe it's kind of like our brain, as opposed to the individual things in our brain that actually store information. That's as we get closer to the processor, when we think about the CPU registers, things like that, much smaller but much faster memory locations. From a human being comparison to a computer, we can probably think of that 8 or 16 or 32 gigabytes of system memory as kind of like our brain. This is the memory that we're feeding off of for real-time computing, right? We're not having to delay and go and look up something someplace else. So that means when we double click on that icon, Microsoft Word or whatever, and you know, it takes a little bit for it to launch, it's gonna get loaded into memory, and or at least part of it's gonna get loaded into memory. So it's kind of prepared for quick access for you to look stuff up related to that software very quickly. You know, when you click on the file menu in the upper left hand corner, some code runs that makes that happen. Well, we want that code to be readily available. We don't want to have to go and search for it someplace else. All right, so the question that was posed here a minute ago was, what if we had a computer that only had 4 gigabytes of memory, which by today's standard would be very little memory? You're going to notice some lag, some delays, things like that. It would still work because we kind of have a backup plan. Okay, it would still work, but what would happen is, if you, like you use an example, if you were in Chrome and you opened up many tabs or something like that, each one of those tabs might have some stuff happening on them that's utilizing some of your system memory. So when you flip between tabs or you flip between applications, maybe you have your email open and Chrome open and a word processor open, something like that. When you switch between applications, you're going to notice sluggishness. And the reason for that is your system memory, your 4 gigabytes of memory, was not enough to remember all the stuff that it needs to remember for the things that you currently have open on your computer. So what it does is it fakes having more memory through something called virtual memory, where on your computer's hard drive, which we'll talk about here in a minute, you have kind of like little notes. Okay, it's that's kind of like when I mentioned, maybe you have a piece of paper you've written some stuff down on, or maybe it's in the notes on your cell phone, where sometimes when you got to go look up that social security number, you don't have it readily available, so you jump to someplace else where you know you can find it somewhat quickly, but not immediately, right? There's going to be that little delay. So that's what happens. The computer always feeds off of system memory, and if something that it needs is not in system memory, we have to get it into system memory. So something called swapping has to occur. So we're going to go and look at virtual memory to try to find the thing that we need. Once we find it, we're going to swap it with something else that's in real memory. So the real life example would be this, something like, well, in order to get my social security number, I have to temporarily forget my name. I need to make room for my social security number inside my brain. So I'm gonna forget my name. I'm gonna put that in virtual memory, and that will allow me to bring my social security number into my brain so that I could use it right now when I need it. Okay. Something along those lines. That's where those delays are coming in, when we're moving stuff from our hard drive, virtual memory on our hard drive, into system memory so that we can problem solve with them in real time. And so if you don't have enough system memory to hold the stuff that you need readily available to you as you're using your computer, it's going to be having to do that swap stuff pretty often. And that swap stuff is considered to be slow. That's the point where the human being starts feeling it. All right, because one thing you want to do, is start thinking about your computers as basically a piece of technology that's entire job is to deceive us, right? Its job is to convince us that it can do all these things instantaneously. We use computers as tools, and when we ask a computer to do something, we expect it to immediately do it, right? And one of the jobs of the computer we mentioned earlier with multiple cores in your processor, even though most of the time you might not be using all of those cores, the fact that they're there and ready allows you to do 2 things at once, 4 things at once, stuff like that. So again, our computer is there to make us feel like things are happening simultaneously. Either things that can happen in parallel will happen on multiple cores, or things that can't happen in parallel happen quickly enough um, that we're convinced they happened at the same time, even though they happened in sequential order instead of in parallel. All right, that makes some sense. So that's where the speed of your processor comes in, that clock speed. An example I'll often use is something with, earlier, I think it was Galib mentioned something along the lines of, that he uses, sounds like he does some design stuff with Photoshop and that where he needs to do some rendering. And those are types of things that do benefit from multiple cores. So a real life example of that would be let's say snow. We're in snow season now. Let's say that this entire class, our job was to clean up the snow around campus. Okay, rather than having the trucks come through, we'll just save some money and have our grad students do it. Right? It's good for the body exercise. All right. Well, let's just say that Waleed here is really, really, really fast at shoveling snow. So he can shovel snow at speed 10. Now, the rest of you are terrible at shoveling snow. You can each shovel snow at speed 2. All right. So if any one of you is in a direct competition with Waleed, you're going to lose. Waleed can shovel snow quicker than you. But shoveling snow is something we have this entire campus to do. So we can ask Waleed to shovel all the snow on campus all at once. He's not going to shovel everywhere on campus at the same time. He's going to sequentially go from parking lot to sidewalks, whatever it is, to do it. And even though he's very fast and he might be pretty efficient doing that, because he's not able to do shoveling in parallel, and there might be some sort of maximum speed in which you can shovel. So he's capable of shoveling at speed 8, but maybe because of the current temperature, or you have cars that are pulling in and out of the lot, whatever, he's actually only able to shovel at speed 6 during this during this job. So even though he's very efficient at it, it's going to take him a while. Now, if the rest of the class can each take a part of campus and work on shoveling, each of you is working simultaneously. You're working in parallel on your own little part of campus. And even though you're not as fast as Waleed is, but you might be maximizing your performance. So your performance is a 2 or a 3, and you could go all the way up to a 6 in terms of being able to do that. You can't keep up with that, but that's okay. You're doing your part. You're doing as fast as you can. But because that particular job can be divided into multiple pieces in parallel, chances are having more people or more cores will allow you to solve that problem more quickly than having one very, very fast core like Waleed to shovel all the snow around the department. Okay, so that's where multiple cores comes in, where you have some tasks that require lots of workers to be working on the task simultaneously rather than one super fast worker, because they may not even be able to perform at their highest speed because they might have other limitations, and that task just benefits from being subdivided. An alternative task might be, the old joke, how many people does it take to change a light bulb? If Waleed can change a light bulb at speed 10, and the rest of you can change a light bulb at speed 8. Well, it doesn't matter that there's 7 or 8 or 9 other people. Waleed's still going to win because that's not a task that can be divided up. It takes one person to screw in a light bulb. So whoever's fastest at screwing in the light bulb is going to win in the race of screwing in light bulbs. All right, makes some sense? All right, so everything we're dealing with deals with speed. And speed, it can be measured differently depending on the types of problems that we're currently solving. Now, with that in mind, that memory thing, we want to be operating off of our fastest memory possible as often as possible. So the less time we need to go and look stuff up, the more efficient we'll be able to solve problems. That's the same thing in real life, correct? One thing I like to do is I like to connect, kind of this cryptic technology stuff, which we can think of as being kind of hard. I want to connect it back to how human beings solve problems, which you have a whole lifetime of experience with. And hopefully you start seeing that, oh, they're pretty similar. So, the idea is that computers are actually built in kind of our image in terms of the way we like to solve problems. Okay. All right, so you want to have, let's call it a minimum of 16 gigabytes of memory today as a professional, technology user, so that the things that you're likely to be doing on a computer can all, can largely be stored in fast memory. So when you need it, it's readily available and you don't have those delays where it has to go and find it and bring it into fast memory. Okay, so far we've said that we want a good processor with lots of cores. We want or a good processor with enough cores. We want enough memory, but having 64 or 128 gigabytes of memory might be overkill, right? That's kind of like you're somebody who has a great memory. You remember everything. You rarely have to look stuff up, but you have all this empty space in your brain because you remember everything you ever need. But you have room for more. So now you have wasted memory, right? That you spent money on out of your $1,500. You spent money on a whole bunch of extra RAM that you're never going to use. All right, what else? So what else are you going to consider when you are buying your laptop with your $1,500 budget?
Graphic card.
Graphics card, okay. So what are applications where the graphics card makes a difference? Why would you want to get a better graphics card?
I mean, a few applications just need their own uh, memory to finish their task real quickly. So
Okay.
some tasks need to be assigned to that particular application more quick for
Okay.
more.
For example, what kind of tasks would be um, would require a good graphics card? Good, whatever that means.
I mean, all multimedia applications take the graphic card's memory and just to quickly finish the task, and few game development softwares.
Okay. Or games, right?
Yeah,
If you're using your computer to play video games, those things are going to be, there's lots of stuff happening on the screen at once. There's explosions and animations and all sorts of stuff in our video games, and those are things that effectively a graphics card. Sometimes we call it a GPU. A GPU is kind of a computer in and of itself, right? It's got a processor. In fact, it's got a lot of processors, got a lot of cores in it. And it has some memory built in specifically to remember stuff that's happening. It's considered to be very fast memory. And generally speaking, what GPU processors are good at is floating point math. Okay, when we think about our normal processor in our computer, your Intel Core i5, Core i7, whatever processor, that's what's called a general purpose processor. Okay, a human being in general is a general purpose problem solver, right? We all know how to do all sorts of things common to all humans, right? So assuming we don't have any major disabilities or something, you know, if we have our hands, there's something that there are things that all of us know how to do with our hands, right? We can pick up a coffee mug, we can carry something, you know, all sorts of stuff. So just the fact that we're human, where there's kind of this assumed collection of things that we all can accomplish, that we all can do. All right. So we can think of that as we're general purpose. Now, at the same time, there are some specialists out there, right? So there are some humans that have some specialties in things that are beyond what the generic human can accomplish. All right. So maybe we have, well, we can use Waleed as our example. Beyond his normal human stuff, he can also shovel snow really, really, really fast. So if we were having to perform a task that really leveraged him, his snow shoveling prowess, his abilities in snow shoveling, if we had that, then we would call upon him to come and help us solve that problem. Similarly, if you have a leak at your house, you call a plumber who can come and help with that stuff, because I don't know what I'm doing. I can apply some of my common human problem solving and try to wrap stuff with duct tape or whatever, but we all know that there's a pretty good chance that's not going to work out, at least not for a very long time. All right, so you want to get a professional to come in, somebody who has some very specific types of problem solving skills that are very specific to the kind of problem that needs to be solved. That's what a GPU does. A GPU does not have general purpose processors. It doesn't know how to do all of the things that your Intel processor can do, but it knows how to do a couple of things really, 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 really fast. Okay, so just generically speaking, it knows how to do floating point math really, really, really fast, which tends to be very important for showing lots of things, lots of pixels on the screen at the same time. It has to do with polygons and um, translating them through 3D space and that kind of stuff. There's a lot of math going on. All right, and your graphics cards are very good at that math, and your graphics cards have lots and lots and lots of cores, so they can do all that math simultaneously. Okay, so if you're going to use your machine for video games, you want to have a good GPU, probably the best GPU for that. Now, you mentioned something with multimedia. So let's say you're somebody who's like, you know, does a lot of computer animation. So you're not necessarily playing the game, you're the one who's building those animations. And at the end of your design phase for that, there's a rendering phase, right? Well, we can even talk about from compiling software, but let's just use the design phase with the rendering phase. So once you've designed your animation and you're ready to render it, which effectively turns it into a video, let's say, okay, there's a lot of math that goes into it. So having a better GPU will allow you to render that faster. Now, for some of you might not care. Maybe your job has you designing animations and things like that. You can test them in real time, but then so that's just a matter of having a good processor. But then when you're ready to render, maybe it's at the end of the day, you just start it rendering and you leave. You don't care if it takes 5 minutes or 5 hours. You're gone. Computer's doing the work. All right. But if you're doing a lot of that stuff and you need results quickly, maybe during the day you're rendering stuff and then testing it and rendering stuff, then testing it. You want your computer to be able to do those things quickly. So you're efficient in your problem solving, and that's where a better GPU would also come in, is to be able to reduce the amount of time it took to render those things. All right. So better GPUs equal better things on the screen faster. Okay, or better things being prepared for ultimately being displayed on the screen. Okay, so that's a GPU you might spend money on. What else?
I
What
have a
else
question
is
here.
in your budget? What was that?
I have a question here.
Mm-hmm.
So sometimes when I'm using these applications on multi-purpose multitasking, so it gives me a message like out of memory. Is it a system memory or for a graphic card memory?
Well, it depends on what the application is. My guess is if it gave you an error, it's probably system memory, because graphics memory is used for solving real-time problems. So it's probably system memory, but it would really depend on the application.
Okay.
All right, so what else do we pay attention to when we're buying our new computer with our $1,500 budget? What else is important to us?
I think energy efficient.
Okay, maybe energy efficiency. Maybe it's battery life. So, if you're going to be, if you're going to always be working at a desk and your laptop is plugged into the wall, you might not care how long the battery lasts, right? So for those of you who, are going to get, you're getting a gaming laptop that's portable-ish or something like that. That's not something you would probably take into a coffee shop and sit and work on for 4 hours. Okay, because it's, even though it can be very good at playing a video game, you're maybe only going to get like an hour of battery life while playing a video game on that thing, and it might even be less than that, because having that, big beefy graphics card is going to take up a lot of your electricity that's stored inside that battery. Okay, but typically if you're a gamer, you're going to be set up with your, on a desk somewhere, and maybe you have your gaming machine in laptop format, because you do move between school and work and home and things like that. So maybe you're using that laptop for multiple purposes, but wherever you go, you plug it in. So you're not necessarily all that dependent on the battery. So that might be one thing. Now, if you're somebody who uses the laptop specifically for business and you're always on the go and you rarely have it plugged in, well, maybe that battery life really makes a difference to you. You want a battery that'll last 8 or 10 or 12 hours as you use it throughout the day for work, and then you come home and you plug it in. I commonly will take my laptop into a coffee shop or something like that and sit there and do something for 2 or 3 hours. So I want to make sure that my battery life is going to last that length of time. And so part of the trade-off is that, like my laptop has a pretty good GPU in it, but it has the software allows it to switch between the powerful GPU and the built-in graphics card that just can drive my screen of my computer and isn't really meant for performance. So it uses the tool that is most appropriate for the work I'm doing, right? Right now, I'm probably using just the normal GPU, not the powerful GPU, because I'm not playing a game or something, but it's possible with the recording thing, it uses the more powerful one. But my guess would be, as soon as we're done with the Zoom meeting and I go to, and I stop the meeting and then it renders that video, that's when it would switch over to the more powerful GPU. Okay, so our operating systems have become smarter, where you might give it both tools and then it kind of picks the one to use when it's most appropriate to try to give you a little bit more battery life and that kind of stuff. And a lot of times the thing that drives, so I would, this is probably mostly a truth, that the longer lasting your battery life is, the smaller your screen is on that laptop. That probably is true up to a point, because if the screens get very small, well, then the rest of the laptop tends to get a lot smaller, which means you have a smaller battery as well. But when you start thinking about, like, maybe if we just keep it with Apple as our example, like the Macbook Airs. Well, the Macbook Airs are very light, very portable. They're not the most powerful machines in the world, but they're powerful enough to do the things that many people, including computer programmers, might do throughout the day. That typically is going to come with a little bit smaller computer screen. Maybe it's a 13-inch screen instead of a 15 or larger screen. But you're going to have a battery that lasts all day, and you're not going to have to constantly be charging your laptop. Similarly, if you are somebody who is doing, at work, you're doing graphic rendering type stuff, and at home you're playing video games, you're going to care less about that battery life. But you probably do care about having a larger screen. So now you're going to get one of those laptops with a 17-inch screen, or there's even ones with bigger ones, but let's just call 17 is the biggest, with like realistic laptop size. So now you have something that has that bigger screen because the assumption is being made that you're usually plugged in. The bigger the screen, the more power it takes to drive it, right? Is the idea. That's why I see, I see this all the time with students who have some older laptops, and they turn the brightness way down on their laptop to give them more battery life, because the stronger the light is that's backlighting your laptop, the faster you go through your battery. Well, I have old eyes, so I can't see usually what's on their laptop screen. I need my screen bright like the sun. It's gonna light up. Otherwise, I can't read stuff. But those are the trade-offs that you make. So power efficiency is certainly a decision you're going to need to make, but realistically, rather than saying it as power efficiency, you might think about it as kind of that portability trade-off. Is this something I'm going to be mostly using unplugged into the wall and on the go, or is this something I'm usually going to be parked at a desk with? Like I'm usually plugged in with my laptop, except for when I'm at a coffee shop. So I tend to be out and about and, at a lot of different places. So I need something with good battery life. But at the same time, if I'm doing something like this, like right now, I'm at my desk and I'm plugged in, so I'm not draining my battery. So as soon as we're done, if I want to take my laptop with me, I have a full battery to go and do whatever with. Okay. So what else?
Number
What
of
else might? What's that?
number of ports.
Number of ports. Okay. Sure. We maybe care about the number of USB ports or stuff like that. Again, for the types of problems we commonly solve. A lot of us have these dongles and stuff, right? That, especially if you're an Apple user. Well, now you're in dongle hell. Um, uh, Now, it actually is a funny historical thing from and it's related to this class. So, I mean, I'm not really getting off topic with this story, but one thing, I'm guessing if I poll the class, we're probably going to have about 70% of the class probably are PC people. 30% of the class are Apple people, or at the very least would be Apple people if they could afford it. Something like that. Okay. Same thing as in real life, right? You might have car people that really want a Mercedes but can't afford the Mercedes, or replace Mercedes with, fancy car of your choice, whatever it is. Okay. But we can all, whether you like Apple or hate Apple, we can all agree that Apple's a big deal in the tech industry, right? They're one of those big giant top companies that when they do something, everybody else has to listen whether they agree with it or not. Fair enough. Okay. Well, so Apple was actually one of the leaders way back, and I use this example. So if we're going into mobile a little bit, how many, out of curiosity, we probably have, I'm guessing, roughly 50-50. How many of you are Android? In fact, actually, here we're going to be a little interactive. I'm going to create a poll. I'm just interested in the answer to this. Android versus iPhone. All right, so I saved that. So now I should be able to go to polling. There we go. Launch poll. So answer that question. How many of you are Android users? How many of you are iPhone users? Is that everybody? No, we got 9 people. Somebody's not answering. Okay, does the 9 include me? All right, well, we'll call it good there. I don't know if you guys can see the results of the poll, but out of 8 people who answered, we had 4 Android, 4 iPhone. So, and most of us would have probably guessed at those results, right? So there's your polling results. All right, so so the reality is so I like to mess with the Android people here. If you remember back in the early days, and actually some of you were were pretty young at that point in time, so this might be going back a little bit too far. But in the early days of iPhone versus Android, so let's call it 10 years ago. So, most of you were, youngish teenagers probably at the time. But, all the Android commercials were ripping on Apple for not having multitasking. They didn't have flash support. That was the big one, right? Multitasking and flash support were the two big things. So flash is used on like websites that have a lot of like built-in animation type things. It was a technology built by Adobe that's finally been kind of phased out. Do you know what technology replaced flash? And this gets back to my example of Apple being a big fish. So the technology that replaced flash is HTML5. All right. So there was a point in time, probably, I don't know, maybe 7 years ago. Might be sooner than that, but whatever, something in that ballpark. Not like 2 years ago. I think it was 5, 6, 7 years ago, where there was go ahead.
It's 6 years.
6 years ago, when there was a kind of a big war between Flash and HTML5. Flash had been around for a long time, and HTML5 was this new kid. And any websites that had a lot of interactive type stuff on it, those were implemented using Flash. Now, the problem with moving to HTML5 is that was going to require all of these websites, the people who manage them, to have to update their websites to work. So one thing that Apple did is they said that we do not support Flash. They said they do not support Flash. So they were only going to support HTML5. Now, so what does that mean? If you want people to be able to see your website on an iPhone or an iPad, you better switch to HTML5. Now, if you're Bob's Computer Company and you have something that, you have the tablet you just invented, nobody's going to listen to you. Fine, our website just won't work on your tablet. But if you're Apple, you might not like it, you might not agree with it, but you probably want your website to work on the iPhone and the iPad, right? So Apple put that line in the sand. It said, we support HTML5, we do not support Flash. And all of the Android commercials at that point in time, they would be bragging about how they like, oh, we have Flash support and stuff like that. But one of the funny things, first of all, how many of you who are Android users like the fact that your phones can do Flash? Do you use the Flash ability all the time?
I don't mind. I just use for applications and calling purpose. That's it.
Okay. But do any of you like the fact that it supports Flash, and just in case you run into a website that has Flash on it? Or have you never run into that situation?
I think we never ran into that situation.
Okay, well, that's good, because you know what happened? One of the biggest complaints that Android users had back in those days was battery life. The iPhone's battery life was way better than Android's battery life. And that was for 2 reasons. Well, multiple reasons, but realistically, do you think the batteries that were inside of the Android devices were different technology batteries than were inside the iPhone devices? Or they were probably fairly similar capabilities. In fact, maybe pretty often the Android devices had larger batteries but they had much, much, much shorter battery life. Why is that? What do you think? Why was the battery life so much worse on an Android device that even had a bigger battery
Number
than
of
it was on an
applications.
iPhone? What was the
Back-
answer?
background applications that's running on the system.
Yeah,
In the-
background applications. Oh, you mean multitasking?
Not
So
multitasking. I mean, they're just.
well, it was multitasking,
I mean, we are not using, but the system keep using those applications.
but you were using as well. So if you remember back in the early days of iPhone, you could not have your music playing, for instance. You couldn't have Pandora going and be checking your email. If you wanted to listen to Pandora, you had to have that front and center. On Android, you can put those things in the background. So you had multiple apps running that you were currently running. You also had, like you mentioned, background processes that are just part of the operating system running in the background. Now, both of them had that then, but we're talking about user-based multitasking. So on Android, if you opened up a bunch of applications, those were all using battery life and processing power and stuff like that. In fact, for a long time, the most popular apps on Android were apps that allowed you to close other apps. So you would download an app on Android that you launched that made it convenient to kill off apps you weren't currently using so that you get a longer battery life. That was common. that was a common thing for Android devices. So now, and you could even recognize this on a laptop, the Flash support. The mobile version of Flash is deadly to a laptop or to a battery. If you go, even to this day, if you can find some website that has still has Flash on it, not just the mobile version. The mobile version of Flash is just terrible. It doesn't even function well. So the fact that you have it doesn't even matter, because if you go to a website that requires you to use it to see the website, your user experience is going to be terrible. But even Flash in general just uses a lot of power. So even today, if you can find some website that has Flash still on it, unplug your laptop from the wall so you're running off battery power, go to that website, and you're going to see how badly it'll go through your battery like nothing. If you have a 6-hour battery life, usually, I bet you get 45 minutes on your laptop today. All right, so Flash is, and it's not that Flash was bad, it was just built during a time when it didn't have to think about its power consumption. It was writing those applications for computers that were going to be tethered to the wall. Electricity was going to be flowing all the time. No big deal. Okay, so Flash was an inefficient power application. Apple had the leverage to say, well, we only use HTML5, switch or your stuff won't work on our devices. Okay, not much of a choice there. Similarly, the multitasking stuff, now iPhone supports multitasking. iPhone kind of created a mobile friendly version of multitasking. When an application goes into the background, there's like 6 or 7 little different hooks it can connect to. For instance, play music might be one of them, where the entire application is not running in the background, but a portion of it is running using just that hook. So it uses a mobile mentality based multitasking system. When Android's multitasking system was not a poor multitasking system. Android is based on top of Linux. Linux is an operating system that's built to run on a computer that's plugged into the wall. It's not thinking about battery life. It's not trying to take shortcuts to make your battery last longer. So the things that Android used to brag about were the reasons why its battery life was so poor. Okay. So that's kind of our power efficiency stuff. And I'm going to put a little note here for where we left off. We're going to start talking about hard drives next class and what decisions we make there. And then we'll start diving into some of the other stuff. All right. So no homework for Wednesday, but and actually just before I forget, I know some of you already, well, many of you already have this, but if you go to cuwcs.slack.com, create an account using your cuw.edu email, then join the CSC548 channel. This is where I will often make announcements, etc. So we have a Slack channel. It's a good way for you guys to collaborate on homework and stuff like that. So if you don't already have an account with our Slack channel, many of you do if you've been in classes before, go to cuwcs.slack.com. Make sure you create the account using your cuw.edu email. If you have any issues with that, send me an email and I'll let me know the email address you want to use, but I prefer you use your cuw.edu one. It'll let you in automatically. And then get into that channel so that you can see stuff. You might also choose to join channels like the ones, there's ones for student announcements for internships and stuff like that as well. But at the very least for 548, make sure you turn on notifications. So you, whenever I post something in there or somebody else posts something in there, you find out about it. Slack is available on Mac, PC, iPhone, Android. So get it on all your devices so that you don't miss any communication from the class. Sound good? So starting Wednesday, we'll meet in person at 8 a.m. Probably in S109, but we might find a different home. But I will also have the class on Zoom. But like I said, I prefer you to be here in person, but if it's just not doable, you can attend on Zoom. Questions, comments, concerns, bribes?
Will you post the Bible homework soon?
Yeah, I'll post the Bible homework probably today. If not today, then tomorrow. It'll be up by Wednesday. And also on Blackboard, I'll have the slides for the link to these slides and the link for the videos and all that stuff. Cool. All right. I am heading down to chapel. Well, what was the question?
That homework will be for Wednesday or today?
No homework for Wednesday. When I post it, I'll have the due date. I don't know when I'm going to have the Bible homework due yet because it depends on how many assignments I have related to it.
Sure.
But no homework for Wednesday other than making sure you have a Slack account.
Wednesday we will be meeting on campus, right?
Correct.
Okay.
Is there any way you can provide the link on Blackboard for the Slack?
For this link?
Usually, like in the last semester, we usually go on Blackboard and
Yeah, but you want this
click the link.
You want this link right here that I'm circling?
Yeah, usually
Yeah,
there is a
I-
link for the Slack.
Yeah, I can put it on there, but just remember it for now so you have a but get Slack on your phone. All of you have smartphones. Get Slack on your phone so you have it. That way you don't miss things. Sometimes I'll just put stuff up on Slack and I won't send an email about it. So I expect all of you to be on that Slack channel. All right, I will see everybody on Wednesday.